So this is the first of 2 videos on the homework explaining how to get the answers to that one. It's easier for me to upload them that way. So the first thing is it says Benny Flop Benny down here, or Belly Flop Benny, is down here at the bottom at rest on the ground. And so what is his potential energy? Well, remember, I'll write this up here actually, that gravitational potential energy is mass times gravity times height. We'll have to keep that in mind the whole time. And kinetic energy is equal to 1/2 times mass times velocity squared. So down here on the bottom, he's at rest, so his kinetic energy is 0 because he doesn't have any motion at all, and his potential energy is 0 joules because he doesn't have any height at all. So the next question, part B, says, well, where does he gain energy by climbing the ladder? Or what kind of energy does he gain? And where does he gain it from? So he gains potential energy, and this is for part B. So he gets gravitational potential energy, and where he gets it from is he pushes down on the rungs, and then according to the third law, the rungs push up on him. So the rungs do work on him. So the rungs do work on Benny, and the work that the rungs do on Benny becomes gravitational potential energy up there at top. So once he's up top, he dives off and starts to fall down. What happens to his gravitational potential energy, this is for part C, his gravitational potential energy is going to decrease, and it's going to become kinetic energy on the way down. And this is the premise of the conservation of energy that we talked about before we left school on Thursday, that you can't destroy the energy, you can only change it from one form to another. So it says, suppose the rungs do 10,000 joules of work to get him up here. So what does that let us know? That lets us know that up top, when he's standing here, that his gravitational potential energy would be 10,000 joules, and his kinetic energy would be 0 as he was just standing there. Now the key concept for this is the whole time this total amount of energy can't change. So 10,000 plus 0 is a total of 10,000, and so he'll always have 10,000 joules of energy in one form or the other as he goes down. So that was 2A. And by the way, to get him up here, if he's got 10,000 joules of potential energy at top, then the rungs did 10,000 joules of work on him. So now it says he splashes down to a pool. So right before he enters the water up here, what is his potential energy and kinetic energy? Well, if he's basically on the ground here, then his potential energy is 0. But the energy's got to be a total of 10,000 all the time. That means his kinetic energy is a total of 10,000 joules. That's what that says. So 10,000 joules is his total amount of kinetic energy right as he's getting ready to strike the water there. So C says, determine and label the values of Benny's potential and kinetic energies when he's halfway down. So on my line, height 2, that's right here. So if he's halfway down, he's got half the height, which means he'll have half the gravitational potential energy. So rather than having 10,000 joules, he'll have 5,000 joules of gravitational potential energy, but the total amount of energy's got to stay the same. That means to get us back to 10,000, the other 5,000's got to be kinetic. So 5,000 potential, 5,000 kinetic there. So that was C. D says, determine and label the values of Benny's potential kinetic energy when he's a quarter of the way down, so up here. So another way to look at it is, when he's a quarter of the way down, he only will have he's lost a quarter of his potential energy. So rather than 10,000, he'll have 7,500 joules of gravitational potential. And again, to get us back to a total of 10,000, then he's got to have 2,500 joules of kinetic so that we maintain that 10,000. And then D says, determine and label the value of Benny's potential kinetic energy. Sorry, that was D. E says when he reaches the level shown with the star. So the star is right here, and they tell us here that his kinetic energy is 8,200 So right here, kinetic energy, 8,200 joules. So we got to get back up to 10,000. That means his potential energy is 1,800 joules. And then finally, it says when he reaches the level shown with the circle up here, then it says that at that point, his potential energy is 6,400. So we can label that. Potential energy is 6,400 joules. And so what is his kinetic energy? Well, we got to get back up to 10,000. So that's going to be 3,600 joules there.